Hi Sky, this is Jolene. I just got done looking at your homework, and so I wanted to go over a couple things with you that I saw from your homework that you could work on. And one of them has to do with if you have a base to a power times an base to the same power, that's equal to a times b to that power. I noticed on the first one that you did that you had a plus instead of a times, but it's times. And you can see that, if I were to write this out, it would be a times a, dot 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 times a, and this would be m, there'd be m of these, right? And that would be times b times b times b times dot dot dot, b, and there would be m of these, right? And you can see that you could pair up the a's and the b's. So you could have ab times ab times ab dot 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 times ab, and how many of them would there be? There would be m of them, right? Because you could compare. You've got you've got m a's and m b's, and you can pair up every a with a b, and you won't have any left over. So, and then you can see that that would be a b to the m. All right. So, and don't forget that this can go both ways. All right. So, for example, let's do an example here. Actually, the first one, 1.1 number 2. This was section 1.1 number 2 in Singapore book 2. And the problem was 3 to the third times 4 to the third. And that is equal to what? That's equal to, if we use this thing, we can take 3 times 4, we get 12. That will be 12 to the third. Okay? But let's take another example. This is just one I made up. What if we have 12 to the third over 16 squared? Okay? So don't forget that this can go both ways. The 12 is still 3 times 4. So we can write this as 3 times 4 to the third, okay? And 16 is 4 times 4, or 4 squared, so we can write this as 4 squared squared, okay? And then we can write the numerator here as 3 to the third times 4 to the third. And the denominator, we can just multiply these. We have an exponent to an exponent, so we have 4 to the fourth. All right, and then you can see we've got 4 to the third and 4 to the fourth. So this ends up being 3 cubed over 4, right? Or essentially I could write it as 4 minus 3, right? So that's the same as 27 fourths, okay? But, you can leave it as 3 to the third. All right, so that's one example. So don't forget that you can go both ways. Even though this is written as 12, it's a composite number. So 12 is equal to what? It's equal to 2 squared times 3. And so you could have even broken this up further into prime factors. In fact, a lot of times it's a good idea to factorize the thing completely. So let me give you another example. So this is example 1. Here's example 2. I'm going to give you 36 to the fourth over 8 squared times 3 cubed. Okay? So let's break 36 up into its prime factors. Now we know it's either 6 times 6 or 9 times 4. And so if we use 9 times 4, then 9 is 3 squared, right? So it's 3 squared times 2 squared. Okay, so 36 is the same as 3 squared times 2 squared. And the whole thing is to the fourth power. And now let's break this up into its prime factors. So the 8 is 2 cubed, so we can write this as 2 cubed squared, and 3 is already prime, so that is still 3 cubed. All right? And then we can say, we can kind of distribute this 4, and we get 3, well, or we could write it as 3 squared to the fourth times 2 squared to the 4th. And on the bottom here, this would be 2 to the 6th, and then we still have this 3 cubed. And so then we have 3 to the 8th times 2 to the 8th over 2 to the 6th times 3 cubed. And now you can see everything's in terms of prime numbers, okay? Instead of having these composite numbers like 4 or 12 or 16, everything's in prime numbers, so we can't break those numbers down any further. And so now you can see we have 8 2's on the top and 6 2's on the bottom, so that's going to be 2 squared on the top. And here we have 8 3's on the top and 3 3's on the bottom, so 3 of those 3's are going to cancel with 3 of the 3's on the top. So we have, what, 3 to the 5th. Okay? So that would be the way you would express that in its simplest terms. All right. Another example I want to do, there's, in fact, you can take any problem, any math problem involving division and simplify it using prime factors, right? So if I have something like 2880 over, what, 240, okay? Now, you could divide that, but I want to make it simpler. I want to make my arithmetic simpler. So what I'm going to do is I'm going to break 2880 up into prime factors, okay? So I know that's 2 times 1440, and hey, look at that. I can see 144 is 12 times 12, so I can write that as 12 times 12 times 10. Okay, that's a time sign. And then I can break that up even further. Now, 12 is 3 times 4. I'm actually going to write it as 2 times 2 times 3. What did I just say? Yeah, 3 times 4. And 2 times 2 times 3, and 10 is 2 times 5, right? So if we want to write this in terms of its prime factors, we have 1, 2, 3, 4, 5, 6 2's, so 2 to the 6th. And then we have 1, 2, we have 2 3's, so 2 squared, and it looks like we have 1 5, alright? So that's 2880 in terms of prime factors. Now let's do the same thing to 240. So 24 times 10, that's 6 times 4 times 5 times 2, and this is 3 times 2, and this is 2 times 2, and then 5 and 2 are already prime. So we end up with, what? We have 2 to the 4th, right? Because we have 4 2's. 1, 2, 3, 4. And how many 3's? We have 1 3, and we have 1 5. Okay? So now that I've got both those numbers in terms of prime factors, which wasn't too hard to do, I can actually write this fraction, 2880 over 240, I can write it as 2 to the 6th times 3 squared times 5 over 2 to the 4th times 3 times 5. And now you can see, here 6 minus 4 is 2, so we have 2 squared. 2 minus 1 is 1, so we have 3, and then the 5's cancel, 1 minus 1 is 0. So hey, look at that. That's pretty simple, 12. And to me that seems like it's a lot simpler than trying to do some sort of long division where you were, did 240 into 2880. Don't do it that way. Break everything up into prime factors. I want to show you one more example involving some negatives. Okay, so example 4. Let's see. So the example I was going to show you is 3 to the negative 6th times 12 squared over 4 cubed times 2 to the negative 2. Okay? Now when you have negative exponents, the first thing I would do is get rid of those negative exponents. Let's make them positive. And all we have to do is it's just the reciprocal. So if we have a negative exponent on the top, let's put it on the bottom and make it positive. So that's 3 to the 6th, right? And here we have a negative exponent on the bottom, so we can just put it on the top. so that's 2 squared. So get rid of those negative exponents right off the bat. Make them positive and put them on the, either in the numerator or the denominator. And then we can leave 12 squared on top and 4 cubed on the bottom. And then let's break everything up into prime factors. Well, I can see there's a factor of 4 here, so let's go ahead and break it up into prime factors. So we have 2 squared, and then we have what? 2 squared times 3 to the second power, right? 12 squared is the same as 2 squared times 3 all to the second power. And this is 2 squared, so we can write it as 2 squared cubed and 3 to the 6th. So now everything's in terms of prime factors. I probably wouldn't have to. I can see this is a 4 and there's a factor of 4 here and there's a factor of 4 here. I probably could have left a 4, but prime factors are sometimes a little, sometimes a little nicer to work with. So we have 2 squared times, now we have 2 squared squared, so that's 2 to the 4th. 3 squared squared, or no, just 3 squared, so that's 3 squared there, right? So you can see this is 2 squared squared and 3 squared. And then 2 squared to the third power is 2 to the 6th, and then we have 3 to the 6th. So now we can just combine the 2's and the 3's, right? So we're going to end up with, this is going to make 2 to the 6th, and then you can see I have a 2 to the 6th on the bottom. So that's just going to be 1. That all is going to cancel, all right? And then I like positive exponents, so I'm just going to make this 1 over 3 to the 4th, okay? And 3 to the 4th, you could write this, this isn't just 9 times 9, right? 3 squared. 3 squared times 3 squared, so it's 1 over 81. But this is probably fine to write it like that. So there you go. What I want you to do, I'm going to send an email to your mom with some of the problems that I want you to redo, given this explanation, because I think once you've got this down, some of the problems that you marked as not sure how to do will be easier for you. And if you have any questions, you can always email me or give me a call. So we'll talk to you next Thursday. Bye.